Hello, welcome. We are looking right now at parabolas. And in integrated 3, parabolas were written in this format here. Right? Y equals x squared, or with the x minus h and the k out here. Or if it was left or right, we would have the y that's squared. In precalculus, we're using a different format, and it uses 4p instead of a. So this is the type of equation that we're going to be looking at. It really does the same thing, it just has a different way of getting the information. So you'll be comfortable with two ways now. The top set here is when parabolas are going up or down, and the bottom ones are left or right. So I've prepared this paper that starts off with blank quadrants there. With these extra ones, we're going to start with this one here in this quadrant. So let's take a look at that one. You notice I have what looks like XY axis, but it's actually not going to be. So it's going to be as if this was anywhere on the graph and there's two lines. And we're going to start off with what actually essentially makes a parabola, is that you have a vertex here. And you have another point that's called a focus point. And there's a line on the other side of the vertex. Oh, I should put a V by vertex and an F for the focus point. And this is called the directrix. Directrix with an R, I believe. And this, of course, since it's a horizontal line, means it's going to be a y equals some number. Like if that's at -3, we'd have that, or 7 or something like that. Y equals 7 because we're up in that quadrant there. The thing to recognize on this is that there's a specific distance, and I'm going to go to red for this. This distance here and this distance here, basically from the vertex up to the focus point, or the vertex down to the directrix, there's a certain particular distance there, and that's the amount p. Okay, and we're going to get that p from the equation here. So we're using this equation where you see the x is being squared and the y is not. That means that it's going to have this type of shape in some form. So we know that it's going to be p up and p down both ways. We need to find out how much that is. And the way we would do that is we would take whatever amount is here and we make it equal to 4p and divide by 4, and we'd find the amount of p. And we'll do that in another problem in a moment or two. But the other things that you need to know are how to then graph this if you get the right information. And one of the things is a line that goes, I don't want to use red. Let's go over and let's switch now to black. There's a line that cuts right through the focus point, and the focus point is the center of that line. That line is what's called the latus rectum. That's Latin for straight line, because it is a straight line. So I guess because it's a straight line, and academia loves to use Latin or Greek words, and both of those, they just use that. And so get used to it if you're not already. The graph of this now is going to go, and I'll switch back to this blue that I sort of like. The graph is going to go through the ends of the line, so that helps define where the curve is going to go. That's why the latus rectum is very helpful. The other thing that you need to know is that any point that's on here, the distance from the focus point to that point, and then from that point straight down at a right angle to the directrix, those distances are exactly equal. D1 and D1. Now it doesn't look like it on my graph. That's because I am woefully inadequate as an artist. But I can at least give you the idea and concept that they're supposed to be equal. That's why P and P are equal to each other, because from the focus to the point on the line called the vertex, and from that point down to the directrix, those amounts are the same. So that's what it looks like here for this type of graph. We're going up. Underneath it is the same thing, but it would be going down. So if we had this one, I would be putting a point hereabouts for the vertex, and that same distance here I would go to get the focus point. Because in this case, because it's negative, we're going the opposite way with it. We're going down. The focus point goes down and the directrix goes up. So that'll be y equals something there. And then there'll be a latus rectum with a certain amount here and here. Let's go farther out here on this just for the fun of it. And that means that the graph is going to go something like that. And we know because it's negative that it's opening downward. The two on the other side are left and right. Let's come back up here and look at this one. And notice on this one that we have the, and in fact, what I should have mentioned, and now I will mention to make sure that I get it in here. Let's highlight using yellow. Whoops, that didn't do what I wanted it to do. So, no, let's go and see if I can, new program here I have to get used to, and so what I want to do is highlight. Still no, I don't like that it does that. Make it a little thing there, and let's get off of that, and I don't know. Hold on. Well, I don't think I'm going to highlight it. I think I'm just going to go back to drawing here. Okay, but notice that there's a K and an H, and on this one there was an H and a K. The vertex is the H value and the K value. You would change the signs to do that. In this case, the vertex is also going to be H and K, but we'll take the H, of course, from here where the X is, and then the K from the other. And that's going to be somewhere, let's call it about here this time. So that'll be the vertex, and that's H and K. And then let's say that the, then here is the focus point, because this distance here has to match this distance here. So that'll be the focus point. Okay, and in the next problem, we'll figure out how to use that. We'll have to get P and 4P for it. And I'm going to have a very relatively small latus rectum this time, which means that this shape is going to go, no, that won't do it. I guess if it's that high up, we are forced to have, actually forced to have a larger distance there, because this distance here needs to be, I guess, about to here and here, to allow for, when we go to here, yep, we're going to have a pretty big one open up here. And that way the point that's here is this distance, and this distance is supposed to be equal. But because the focus point is here and the directrix is here, we get to go way up and way out, and so it's opening to the right. Now, the negative, notice this was a positive 4. If it's a negative 4, it's simply going to be, here's the vertex, here's the focus point, and then we do a latus rectum, and you notice that it's going this way. So the negative tells you it's going to be going opening to the left. The only other thing I didn't introduce here was the axis of symmetry, and I will bring it up. It's one of the easier things to be aware of. You just have to remember about it. Let's put that in black now. Is that here is the axis of symmetry, and that's x equals, because it's an x line going up and down. You just need to know what the x is. And in this case, it's this one. And here is the axis of symmetry this time. Axis of symmetry. But now it's y equals because it's horizontal, so you just need to know that line. Like in this one here, here's the axis of symmetry. And the directrix is going up and down instead of going sideways. So those are the basic shapes that you'll see until we start rotating them, which we'll do next week, or in another one. That's the next section, actually. So now let's go and look at actually graphing one of these. So let's skip the next two because it's a different part of the topic and go to page 4. We're going to use this equation here. X plus 3 squared equals negative 8 y minus 1. So what we're going to do is find the vertex, and the vertex is simply going to be these 2 points, but it's going to be the opposite sign, the h, so it's opposite. So that's x minus h, which means for it to be a plus 3 means it's minus a negative 3. And then a positive 1 here. So negative 3 and 1. I don't feel that we really have to put that positive sign, so let's just make it 1. Negative 3 and 1. So let's graph that down here. And this time I'll switch over to blue. Okay, so -3 and 1. And so that's where our vertex is. Now, notice the directions for graphing it. You have to put the vertex with V, the focus point with F, and so we'll do that, and then the equations of the axis of symmetry and directrix. So we need the focus point, and that means we need to know how far up or how far down to go. Okay. So one of the things that, because this is x squared, we know it's going to open that way, so the focus point will be somewhere above it, so we're going to be adding to the y. So the focus point is going to be the h and adding something to the y, and it happens to be p. So how do we get p? Well, we know that 4p is in this place right here, so we know it's equal to -8. If we divide by 4, we see that p is -2. So now we know that p is -2, and according to this, I'll do k plus p. That's 1, because k is 1 here, the opposite of the -1. So that's 1 plus a -2, which is -2. So that means our new k is a -1. So here, okay, I want to erase, whoops, not what I wanted. I wanted to erase that and go back to writing it. I'll stick the blue here. -3, because the x doesn't move, but the y does. The x doesn't change. Because, oh, hold on, I'm trying to get this to, I have to do 2 fingers. Actually, it's not moving for me at all. What's up here? It is frozen. Hold on a second and let me figure out how to move this up and down now. Aha, that did it. I can use this thing over here. So let's graph that. That's -3 and -1. It's down. Oh, I just saw something. I did this here, and I didn't pay attention to the fact it was negative. That means it's going down, and the focus point is here, and it forced me to put the focus point there. So if you forget which way it goes, just like I did here, it forces you to go into the right direction. So the focus point is going to be down here. Okay, I'll put F for the focus point. And that means the directrix will be the same distance, which was 1, 2, the same distance the other way, and that's where we're going to draw this line for the directrix. Okay, the equation of the directrix says y equals or x equals. Since it's horizontal, we know that will be y equals, and it looks like it's y equals a +3. So I've actually just done that now as well, and I've done the focus point. So we'll need the axis of symmetry. We can put that before we even graph this. So, whoops, let's come down here a little more. Going up like this. So it's that horizontal line. That's the axis of symmetry, and that one is x equals -3, because all the x's along there are -3. Now, what's next? Let's come back up here, and the equation of the axis of symmetry, x equals 3, and the directrix was, oops, -3. I need to change that. It was the other one that's 3. Y equals +3. The direction of the opening, ooh, now I need to like draw it, but I don't know whether it's this way or this way or this way. It doesn't really matter, because we still know for the, well, for the first question, for this question, it doesn't matter because we know it's going down. It was up or down, left or right are the only answers you can give for that one. So let's find the length of the lattice rectum. And so this is one of the little rule things that you should know. Definitely should include as notes for yourself here, is that the lattice rectum is the absolute value of 4p. Because it's a distance, it can't be negative. So since 4p equals -8, the absolute value of 4p equals 8. Because -8 with the negative removed is 8. So the length is 8. And remember, the lattice rectum goes directly through the focus point. So for this one, I'm going to switch to red to show that clearly here. So here is the focus point, and if I go 4 one way and 4 the other way, probably better if I do them as like dashed lines, because all I have to do is to get to this spot, dashed lines to get to that spot. That's a total of 8. That's the lattice rectum, and what that does now is it lets us go from the vertex through that, and if I wanted to get more precise, I could graph a couple more points, but I have enough here to know that it's going to go probably more like that because it's such a wide open one, like a flower way open, opening up really big. Yeah, missed that one. Okay, that is reasonable there. So that's approximately what it looks like. And what we've done now is successfully graphed it here, and we found all this information: the vertex, the focus point, axis of symmetry and directrix, the equations of them, the direction going down, and getting the amount of the lattice rectum, which allows us to a little bit more precisely graph the equation. So that's a good example there, especially going down one. On your own, if you would like to, you can do this one here, which is a y squared, which means it's going to go left or right, and it's a negative. You would do the same kinds of steps that was done here. The only thing is that when you do the focus point, you're going sideways, so it's the h value or the x value which is going to be adjusted. You're going to add or subtract to get to it. Sort of like this one up here. On this one here, it's going that way means the x of the f of the focus will change, but not the y value because it's on the same y line. All right, let's go back down just to look as a final thing that here are all the information, the way I did it. Did this to find p, and then used p to get the new k, and did this to get the lattice rectum amount. Okay. I'm going to make that part 1 about parabolas and then work on the parts with the equations next, where we're going to change them to the correct form for using them with parabolas. And I'll put this here so that you can write that down as a possible practice problem, and then check to see if you're right in the other things I have available online. All right. Thank you for watching this. Come back and look at my equation part next, please.